For question 11, we need to graph the following system of linear inequalities and identify one solution of the system. So earlier on this formative, we went over using a table of values to graph the linear inequality. There are a couple of other methods, so I'm going to review two of those other methods with you. This first system, this one is written more in something that looks like standard form, and when an inequality is written in standard form, which if we remember is ax plus by equals c, then it's easiest to graph using the x and y intercepts. So to graph using the x and y intercepts, we just plug in 0 for y and plug in 0 for x, and then see what points we get, and we draw the line through those 2 points. So let's plug in 0 for y, and if I plug in 0 for y, that means I'm going to be finding my x-intercept, because remember, this line, the x-axis, is the line y equals 0. Okay, so I have 3 times 0 minus 2x is less than 12. Okay, so this part is 0. So negative 2 times x is less than 12. If I divide both sides by negative 2, I get x is less than negative 6. Okay, so now I know my x-intercept is here at negative 6. Now I need my y-intercept, so I'm going to plug in 0 for x. Because remember, the y-axis is the line x equals 0. So I do 3y minus 2 times 0 is less than 12. So this part is equal to 0. Now if I divide both sides by 3, I get y is less than 4. This means I put a point here at 4. Now this is a less than sign, which means I use a dashed line. So I'm going to draw a dashed line through these 2 points. And next I would shade, but I'm going to go ahead and graph the other one first before I shade. Let's do this second inequality in blue. So this one is written in slope-intercept form. So when we graph using slope-intercept form, we could use a table of values, or we could start at the y-intercept and then use the slope to get to our next point. And remember, the y-intercept is basically when we plug in 0 for x. So if I say y is greater than negative 1/4, and I just plug in the point 0, all of this becomes 0, and I'm starting at the point 1, 0, 1. So right here is one of my points, and now the slope is negative 1/4, which means I go down 1 and over 4. Okay, or I go to the left 4, 1, 2, 3, 4, and up 1. This is also a greater than sign, which means I use a dashed line. So I'm going to draw dashed lines through these points. And now I need to figure out where are the solutions. So on the first one, I'm going to plug in the test point 0, 0. I'm going to go back to red and see, okay, does 0, 0 satisfy the solution? So the inequality. So I plug in 3 times 0 minus 2 times 0 is less than 12. This is both 0 minus 0. Is 0 less than 12? Yes. So that means the point 0, 0 is in the half plane. That's below this first line right here. Okay. Now I'm going to plug in for the next one. I'm also going to plug in 0, 0 and see if I get that answer. So on this one, 0 is greater than negative 1/4 of 0 plus 1. Negative 1/4 times 0 is 0. 0 is greater than 0 plus 1, this statement is false, which means I'm not going to shade in the half plane that contains 0, 0. Instead, I shade in the other half plane. And if we look on the graph, we can see that there's one part of the graph that's only blue. We can see that there's one part of the graph that's only red. And there's another part of the graph that's both red and blue. So this part of the graph is the one that contains the solutions to the system. So you could pick literally any point in here. And we could pick an easy point like 2, 2, right in there. 2, 2. That should be a solution to the system. And we could check our work to see if that's true. Let's say 3 times 2 minus 2 times 2 is less than 12. 6 minus 4 is less than 12. 2 is less than 12. So far, so good. We could check the other one. 2 is greater than negative 1/4 of 2 plus 1. So 2 is greater than negative 1/4 of 2 is negative 1/2 plus 1 is 1/2. 2 is greater than 1/2. That is also true. So yes, our point 2, 2, we have verified both graphically and algebraically. So we say 2, 2 is a solution of the system, or you could pick any of the points that are in this section of the graph that is above and below those two inequalities.